Hey, this is Dr. Corey Glenn, and in this video, I'll be doing a demo of the new Crown and Bridge module in Blue Sky Plan. This is version 4.7.15. Now, if you're familiar with Blue Sky Plan, you probably realize that the software is entirely free and that there's simply a pay per click or simply pay an export fee per case that you design for things like surgical guides, ortho aligners, dentures, and so forth. However, the difference with this Crown and Bridge module is that we've decided to just make it entirely free, so you can use this to make all the crowns, bridges, wax ups, implant restorations, make all of those things at no charge whatsoever. There's not an export fee of any kind on this, so it's a really big value added thing that Blue Sky has done. Now, this module is in its earliest stages, so you can absolutely expect to see lots of future improvements, but it is definitely fully functional even at this early stage. And so let's go through a simple case of just scanning and designing a crown on a lower first molar tooth number 19. Now, whenever you start a case, obviously the first thing that you're going to have to do is acquire the data. That could be in the form of an intraoral scan. That's actually what I'm going to be showing here. Now, you can actually use any intraoral scanner on the market as long as it outputs STL files. In this case, I'm using the Carestream 3600, and I'm just going to let that kind of run in the background so you see the process of that intraoral scan, but we'll just time lapse it and then start in the software. But within the Carestream software, I'm going to do the scanning process. I'll go ahead and align, and if I need to, crop the data, and then we'll take all of that data over to Blue Sky Plan once they've been articulated, and the rest of it we'll do there. Now, since I'm not practicing clinically anymore, you might notice that the teeth look a little different from, natural dentition. That's because I'm doing this on some printed models. But it's the same process if you do it in the mouth versus if I'm doing this on some models in my hand. However, that's not the only option you have. The data could also come from scanning some stone models or even scanning a triple tray in something like the Blue Sky Bio DS3D scanner that we recently released. And what this is it's a desktop scanner rather than an intraoral scanner, and it would allow you to simply take a conventional triple tray impression like you probably already do if you've not shifted over to digital, and then immediately after taking that out of the mouth and drying it off, you could scan that inside of the scanner, and that will generate the same end data. If you prefer scanning stone models, it absolutely will do that as well. And this is just a really nice option because this scanner is super affordable. It's only about $2,500. So in the dental world of toys, that is virtually free. So this really should remove all the barrier to entry to get into digital dentistry. But regardless of which method you go with, intraoral versus desktop scanner, the end point is all going to be the same. You'll end up with upper and lower STLs mounted in occlusion to one another. So as you see, I'm going to go ahead and export the data into STL file format, and then we can go ahead and launch Blue Sky Plan. Now, while the program is launching, let me just show you one other option. If you want a more hands-off approach, you could upload this to labpronto.com, and you could actually delegate off the design or the design and fabrication really as much or as little as you want to do, and the prices are really good. So just to show you this example, I'm logged into my LabPronto account. You can open one of those very simply, and if I just go up here, you can see the different services that are listed on the left. So if I go to order Crown and Bridge services, you can see that we could have a crown designed for just 15 bucks. So suppose that I had my own mill, but I don't want to spend time designing. You could just upload it, 15 bucks, it'll come back to you, and that file will be ready to mill. On the other hand, if you wanted to have them design the crown and fabricate it, you're looking at about $84 a crown. So prices are going to be a lot lower than what you would generally expect from your lab just because it's all being done digitally. There's not any model work to mess with. So you would simply choose what you want to do. Let's suppose here that I just wanted to have the crown designed. I could say it's one crown, patient name, identifying information. You do have the option if you want to pick a specific LabPronto lab to select that from this drop down. If you don't care, then you just leave that blank. Put in your prescription, anything you want the lab to know about this case, special shading type things, and then you would simply hit continue to attach files. and that's where you would upload the two scans that were exported from your intraoral scanner or your DS3D, whatever you're using to acquire that data, attach them here, and then upload it, and now you're done. You'll get a notification that that went through, and then you'll get a notification once the case has been done as well. So for something like this, I could expect to get back just the STL models of the final crown since I've just chosen design. So wanted to mention that real quick, but let's go back over to the software, and you're going to notice that the home screen is a little different from past versions. Now you choose what route you want to go down, and so one of the things we found as we grow this software and add more and more features to it, it just gets bigger and harder to navigate, especially for the new user. So we're trying to go more in the direction of wizard workflows, and this allows you to keep on task, and the software just leads you right through from one step to the other, and hopefully you don't get lost running around through all the different menus, because as you know, Blue Sky Plan is a very large, powerful program, but that can work against you when you're a new user because it's easy to get lost. So since I'm doing a simple crown on number 19, we're going to choose crown and bridge. And this is a conventional crown, so if it's just a crown on a tooth, that's a conventional crown as opposed to one that's going on a tie base or a bridge. So let's choose conventional crown. And this is a really important step. You want to make sure that you go to the folder where you have those files. In my case, I've got it here under this folder. And you want to control select both files or all the files that you're going to be using in a case. Maybe you have a buccal bite that you want to bring in as well. Maybe you have a pre-op scan. But the goal is you want to try to import all of those simultaneously so that when you do the alignment, it happens to all of them in unison, and you're not going to have to be bringing in individual STLs, restitching them, all that. So just hold your control button down and then a simple left click as you're doing that. And here I've got both of them highlighted. So now I'll click OK. And this is the model alignment step. And so this is where we're going to orient the model to the global skull in the program so that it knows which direction is up, which is down. So we've got a quadrant impression here. I usually choose to align via the maxilla, but you can do either or. So I've chosen the maxillary scan over here. It's highlighted blue. I've got maxilla chosen as the type of model, and this is just a partial scan because this was from a triple tray, and now I'll continue to alignment. When you choose that as your method of alignment, the software is going to ask you to indicate 3 points, and those 3 points are going to indicate for it what the occlusal plane is. So I'm going to go ahead and put one on the lingual cusp of a back molar. Then I'm going to go forward and put a dot on the incisal edge. It doesn't necessarily have to be a central incisor, but an incisor edge or canine edge if that's all you got. And then finally one more point on a buccal cusp. I'll click that, and now you see that it brings that in to an overall proper alignment with the skull down here in the bottom left of this screen. Okay, if there's something about that that needs to be changed, when you hit continue here, you do have the option now to reorient this to make it face whatever direction you want. So if I needed to fine-tune this a little bit and maybe put a bit more lifelike orientation on it, this widget will allow me to do that. So I'm just getting it parallel to the occlusal plane. Overall, same orientation as the skull down here. If you need to show all of your models, click the button that says Show All, and that gives you a little bit better visibility of where the occlusal plane is, and we're right through the middle, so I'm going to go ahead and click Finish. So this is a big improvement over previous versions because now that alignment takes effect on all the scans that you brought in. You don't have to come back, import them individually, and then stitch them individually. So that was a big time suck in previous versions. So with that done, we're going to go ahead and click into continue to crown design. Notice that where we are right now is in the new model editing module, and as the name would imply, this is the module where you would do all kinds of buccal bite registrations. You could cut on models, you could edit those models, you could add pins, you can close them. There's a lot of features that you can do from within the screen. So if there's any model work that needs doing, go ahead and do it at this phase, but these are ready to go, so I'm simply going to click continue to crown design. And as you start this process, you need to indicate for the software what type of restoration this is. This is a conventional crown. This is going to be a crown on the mandible, and we have to tell it what models we're building this on. So the model that we're building the crown on is the blue model, so I'll choose it in the drop down. For the antagonist, that's going to be the green model, so I'll enter that. Now the crown, if you're doing this in a wizard workflow, you can just leave that blank, but some people like to come up here at this stage and go ahead and add a tooth and stretch it around and do most of their shaping. Either option is fine. If you want to do that and you've got a tooth that you've roughly positioned, then you would indicate that tooth here, or I could simply just choose the models and click start, and that will begin the process, and I can choose my crown later on in this process. So you see it's carrying us through step by step. The first step is to define the margin. So I like to zoom in quite a bit with the right mouse, and then I'm just going to hold the shift button and drop left clicks all the way around the margin. Now we are working on auto margination, and you can expect that in a future update. But as of right now, this is perfectly fine. You just want to take great care to do a good job on this step, because your margin is only going to be as good on the final crown as it was where you indicated it on the models. So I'm just working around, looking. Sometimes it helps to get a slightly tangential view on this so that you can see a little better where that edge rolls over to indicate the margin. If you make an errant click and you need to move one of these, simply hold shift and grab that point, and you can drag it around to wherever it needs to be, and then just continue on. Now the other important thing that I've seen some people not catch is that when you get to your last dot, you need to hold down shift again and drag that dot into the first, and that closes this perimeter, and now we have a defined margin for the software. I can look at it from above and see everything is clearly visible. So with that done, I'll click next. The next step is going to ask you to indicate your path of insertion. So you can either do that by grabbing the widget and rotating things as shown. If you rotate a certain way and create undercuts, this is what they'll look like. They'll get indicated by that dark brown color. So you could either do it that way, or you could simply look at it from an occlusal view, get it to where you can see all of your margins adequately, and then hit set insertion direction from the view, and it's going to align your path of insertion exactly to however you had that model oriented. This will be defaulted to 0 because we generally always want to block out undercuts in a crown. If for some reason you didn't want to do that, you could allow undercuts up to a certain amount, but I'll click next here. And the next step asks us to define the proximal areas. So if you hit shift, you should see a tool appear, and I'm going to hold shift and then just left click and define where that proximal contact is on both teeth. And the reason that's important is that if you're going to place the tooth later on in this wizard process, it will do some preliminary scaling and size that tooth to fit right between those contacts. Plus later on it's going to be used for subtracting away any of your contact that is impinging into that adjacent tooth. So I'll go ahead and click next. And now if you're doing it the wizard workflow like what I'm demonstrating, this is the point where you could add your tooth. So you've got several libraries of teeth available. I'm going to use the Mitchhurst Flat Anatomy library, and I need to choose tooth number 19 and then simply click OK. And as you see, because we indicated that for the software, it's able to go ahead and drop that tooth into an approximate position that should be pretty close to ideal. And then you should only have to do some fine tuning to tweak that positioning. Okay, so there's a lot of different ways you can approach these things, but I'm going to show you the method that I use to work through this, and I've found this to be the most efficient. So what I tend to do first is to zoom way in here, and I'm not going to position the cusp tips together. I'm going to try to get my occlusal grooves to where they're aligned. So here it looks like I'm coming straight through that second molar, right into this molar, and I want the occlusion, the depth of the occlusion, to be at about the same level on my crown as it is on these adjacent crowns. Okay, so that's a little too high. Right there, it looks like my occlusion is pretty well even. So now that I've roughly positioned the occlusion, we can zoom out a little bit, and I see that I need to close this contact. Now the tool that I'm going to use for that is going to be the local deform tool. And the reason for that is, we could come in with an add tool, but if you just add right on that contact, you're going to end up with this pot belly contact that doesn't really go with the overall anatomy. Whereas if I use this local deform tool, if I hit shift to activate the tool, you can see the spot size. This tool is great for stuff like this because you can actually select a broad piece of the tooth and then pull the entire tooth out. So what that does is it stretches the tooth and still maintains its overall anatomy. I can go just a little bit more, and if I look interproximal, that's kind of what I'm going for. A little bit of impingement, but not much. Okay, and then I also want to make sure that my marginal ridge heights are the same from one tooth to the next, and so I'm actually going to drag that up a little bit and try to get those where they are even. And same thing back here, this one actually can go down to match the marginal ridge height of that tooth. Okay, so that looks good, and now we just need to fine-tune the occlusion, and to do that I'm going to turn on the opposing model. And now it becomes evident why I chose to position the central groove to match the occlusion as opposed to matching up cusps, because invariably when you've got a tooth like this that's got really deep anatomy in it, what will typically happen is that if you position the cusp tips to match up, this is essentially an unworn tooth. It's not had nature wearing it down over the years. And so teeth don't wear out in the grooves, they wear down from the cusp tips. So I would rather position the depth of the groove up to the same level as the adjacent teeth, and then it becomes really easy to just simply take the cusp tips down using whatever tool you want, local deform, add, remove, but I can take a cusp tip down and essentially do the same process that nature does in wearing a tooth down. Okay, so let's turn back on the opposing model and look through in the occlusion, and obviously this is going to be high. So once again, I prefer the local deform tool, and I'm going to pull this back. And I don't have to eliminate every last little dot of impingement. Rather, I just want to get it pretty close. And in the last step of the software, there's an option to cut away those intersections, and we'll utilize that to get those contacts, both interproximal and on the occlusion, at a dead zero. All right. Do any last editing that you might want to do to this. I might hit the contacts with a smoothing tool real quick. And with that done, we're ready to go ahead and proceed to the next step. So back in the restoration design step, we can click Next. And what the software does at this step is to create the crown bottom. Now when you hear crown bottom, understand that to be the internal surface of the crown. And so you've got lots of parameters that can be adjusted here for the crown cement spacer. How big of an area up from the margin do you want? No cement spacer. How do you want that margin to emerge outward from where you've indicated? And the only thing that I need to change from the default here is going to be the minimal thickness. And so I want to make sure that we maintain about 0.5, 0.6 of minimal thickness all the way around that crown. So you see that when I changed that, it reconfigured and made the new minimal thickness on the crown. And so now I can click Next. And in this step, you can see that the minimal thickness is shining through over here on the buccal surface. So I want to maintain that full thickness over here. I'm going to just grab the local deform tool, and let's get a broad brush and just pull that out slightly. And then if you need to, you can come back and smooth that. Okay. And with that done, remember we do still have these small bits of impingement, but notice up here there's two check boxes. One is to cut away the occlusal intersection, so anywhere that this is impinging into the opposing, we can cut that away. And then we've also got the proximal intersections, so it'll cut those away. So when I click finalize, it's going to make my final crown. And now we have the final crown, and we're back to pretty much the base menu. So if you take a look at these contacts now, you're going to see that it has the stippled appearance, right? That's a dead zero of contact between one model and the crown. You can also see that same appearance right around the margin where we have a no cement spacer gap. And everything is looking good here. If I turn on the opposing model, you can see that now there's almost nothing shining through. It's once again a dead zero. If you wanted to, you could come back, and even after you've designed the crown, you could use the teeth editing panel, choose that crown in the custom in the active model menu, and then maybe take a smoothing tool and just give that a tiny little touch to minimize that. You could also use the add and remove feature. So if you remember, holding control is going to be remove, holding shift is going to be add. All right, so now our crown is finalized and it's ready to be exported. So I'll simply do that by going to File, Export Data. And anything that you have checked on in this menu is going to all export as a single STL. So I want to turn off the two models and only export the crown. You can see it does list how many exports I have remaining, but remember that when you're doing crown and bridge things in Blue Sky Plan, it's not going to deduct one of those exports. So I'll simply click export, and we can save this as custom crown inside of the menu of your choice. And now that file has been exported and it's ready to be sent wherever you want to mill it. If you have a mill in-house, it's ready to be milled. You know, if you were doing this for some long-term temporaries, you could even print this, and that would be a good solution to make a really strong and a very nice temporary that's got very defined margins and a really good fit. So there's just a lot of applications with this. You know, you could load this to labpronto. You could do your own design and then just have them mill. There's a lot of different ways you can go with this. So I hope you found that useful, and I'll try to follow this video up with some on fabricating bridges and implant restorations. Thanks.